Good morning. This is the video for section 2.7, and your last assignment was numbers 26 through 30. This video will just go through 26, 27, 28, and then I will post one last answer key video with 29 and 30. All right, here we go. 26 says an airplane is flying at an altitude of 5 miles and passes directly over a radar antenna. When the plane is 10 miles away, miles in fact has an L. When the plane is 10 miles away, D equals 10, the radar detects that the distance D is changing at a rate of 240 miles per hour. What is the speed of the plane? Now, if you're doing this in your textbook, it uses the letter S instead of the letter D. But since my S's look like 5s, I changed S to D. Also, it's just kind of fun to say DD, DT, which I'm going to have to say here in a second. So, like with the other ones, let's clarify what information is given to us and what information is being asked. So it told us the altitude's 5. You'll notice that means that I labeled this like that 5 can stay a 5 because that altitude does not change as the plane flies. When the plane is 10 miles away, the radar detects that the distance D is changing at 240. So it's telling you that dt equals 240. And it's asking for the speed of the plane. Well, there's the plane is over there. I didn't draw a plane this time. It's flying away from the radar station. So I want to know the rate of change of that distance x. So it wants me to find dx dt. And it wants me to find that when it says when the plane is 10 miles away. So that's when d equals 10. All right. So we have, when we've seen this before, we have three sides of a right triangle. So it's a Pythagorean theorem issue. And for what it's worth, all three of these problems, 26, 27, 28, are all Pythagorean theorem related. So my Pythagorean theorem says x squared plus 5 squared equals d squared. And remember that 5 can be a number because that distance doesn't change. The other ones have to be variables because they do change as the plane flies. So we're taking the derivative of that with respect to time. So the first term becomes 2x dx dt. 5 squared is just a number whose derivative is 0. And this is, in fact, 2d dt. And you should probably say that out loud a few times just to enjoy it. 2d dt. So now I got to substitute in some numbers here. And some of these I have numbers for. So it's 2. I don't think I have a number for x yet, so I'll come back to that. Dx dt, the problem told me was, no, that's what I'm looking for, dx dt. Equals 2 times d, and this problem said when d equals 10. And dd dt, the problem told me was 240. So at the moment, I need x. So again, we saw this yesterday. At the point where the distance happens to be 10, and that's 5, it wants to know that. Now, you might recognize that as a 30, 60, 90 triangle. It's going to be 5 root 3, but that wouldn't have to jump out of you. So we could do 5 squared plus, that's a squared, plus x squared equals 10 squared. We get x squared equals 75. It's 100 minus 25. So x is root 75, which is 25 times 3. So it does turn out to be 5 root 3. So that goes here, 5 root 3. Now it's just a matter of solving this. Heck, I see 2's in it. I can divide both sides by 2. Those go away. I see this as dx dt equals 2400. That's 240 times 10 divided by 5 root 3, which turns out to be 480 over root 3. Now, if the answer choices were a decimal, or going to ask for a decimal, you could certainly just get out a calculator and divide that. You should remember how to simplify radicals. This is 480 root 3 over 3. You'll recall that's multiplying this by root 3 over root 3. And then that simplifies to 160 root 3. And again, you certainly could make that a decimal. Unit is miles per hour. So fairly straightforward Pythagorean theorem application of a related rate problem. All right, 27 and 28 both have to do with a baseball diamond. And if you don't know what a baseball diamond is, it tells you. It says the baseball diamond has the shape of a square with sides 90 feet long. A player is running from second base to third base, so that this person is running kind of in, here's the dude right here. He's running this way. And he's running at a speed of 25 feet per second. So that distance right there, the distance between him and third base, that's his rate of change of that. And in fact, since he's running towards third base, that rate of change is negative. So dx dt is negative 25. And it wants to know at what rate is the player's distance d from home plate changing? Again, the book uses S, but I'm going to use D. So it wants find d, d, dt. When does it want that? It wants it when, 20 feet from third base. So that's when x equals 20. And that's pretty straightforward there. I'll warn you right now that in 28, the way the problem's worded is trying to trick you. So just be aware of it for later. So again, I have a Pythagorean theorem. I have x squared plus 90 squared equals d squared. So that's the equation I'm going to take the derivative of with respect to time. So again, I get 2x dx dt equals 2d dt. I told you it was fun to say. Again, we have to worry about plugging in numbers here. So I have 2. This time it gave us x when x is 20. The x dt it gave us was negative 25. So we have numbers for that side. Now I need d. So again, I have to Pythagorean theorem it up here. I'll draw this small-ish. So at the point where that's 20 and that's 90, I need to know d. So it's 20 squared plus 90 squared equals d squared. D squared equals 8,500. So d is the square root of 8,500. And I actually could clean that up. That's 85 times 100. That is 10 root 85. Not that you'd have to simplify it, but I think I will. So that goes in here, 10 root 85. And I have no more light. Okay, so now let's solve this for d dt. Again, I see 2's that cancel. Again, you could do some more cancel. But at this point, I'll just, let's see, 20 times negative 25 is negative 500. And I'll divide that by 10 root 85. And that is d dt. Can I clean that up? Negative 500 divided by 10 is negative 50. And I might rationalize the denominator over 85. And now I guess those both divide by 5. I get negative 10 17ths, negative 10 root 85 over 17, which is negative 5 point something, whatever it is. This is miles per hour. Does it make sense that rate is negative? That's d dt. So as the dude's running to third base, that distance d is in fact getting smaller. So that does make sense. Okay, so there's 27. I might need the light to see my work for the next one, so I'm going to walk over here for 3 seconds. All right, last one is 28. And it's very similar with one small exception. It says for the baseball diamond exercise in number 27, suppose the player is running from first base to second base, putting on my sand hat because it's very cold in this classroom, at a speed of 25 feet per second. So now he's running from first base to second base. So the dude is here. So that distance x, his distance from first base, is increasing. So here dx dt is positive 25. And now here's where the turn of confusion. It says find the rate at which the distance from home plate is changing. So that's not new. It wants us to find the ddt, but it says when the player is 20 feet from second base. That's trying to trick you. That distance right there is his distance to second base. When that is 20, you've got to know that x is actually 70. So it's very tricky. This problem could have said, find this rate when the player is 70 feet from first base, because that's the distance we call x. So you've got to know that this wants to know dd dt when x equals 70. Real easy to put it 20. All right. From here, it's very similar. I've got x squared plus 90 squared equals, that's an equal sign apparently, equals d squared. My derivative is 2x dx dt equals 2d d d dt. Again, I have to plug in numbers. I have 2, I have 70, I have 25, right? Isn't that what dx dt was? Equals 2 times I'm not sure what. And I'm trying to find d dt. So again, I need d. So I've got this triangle where that's 90 and that's 70, and I want d. So that's 90 squared plus 70 squared equals d squared. So that's 130,000, I believe, or 13,000, 8,040, yeah, 13,000 equals d squared. So d is the square root of 13,000. 13,000 is 130 times 100, so that's 10 root 130. So this goes here, 10 root 130. Now we just solve that again. So 2 still cancel out. 70 times 25 is, I don't know, 1750, I think. 1,750 over, over 10 root 130 equals dt dt. And since I cleaned up the other ones, I'll clean up this one too. The zeros go away, I get 175. And if I rationalize it, times root 130 over 130, both of those divide by 5. I see it as 35 root 130 over 26 equals d dt. And that's miles per hour. So that is, you're good. So that is the end of this video. And like I said, I will post one more. Have a great, whatever day it is, Friday, and have a great holiday.